Okay, welcome again. In the previous clips we discussed the binary to decimal and to binary conversions. We have seen digits of 5, 8 and smaller ones as well, and then that led us to the IPv4. We said the IPv4 contains 4 octets and we divide them 4 x's, for example, just as a representation. And each octet contains 8 bits. They can be ones and zeros. If we assume at this time it's all ones and we count them 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 and 8. Now that's a little bit longer. 8 and then 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8. The total of those those bits, they're 32. The IPv4, we said it contains 32 bits. So 2 to the power of 32 bits is how much we have as IP addresses available to us. That number seemed too big at the beginning, but then it's been overused and then we don't have enough. IPv6 then came, that's much larger, which is 2 to the power of 128. 2 to the power of 128 is a large number, but for this, since we're using it, then we need to learn how to actually economize it and use it sparsely or use it efficiently. So to understand that, first we need to actually understand the construction of IPv4. We said the octets, 8 of them, they can either be 1 or 0. So the zeros, if we say a 0 here, that will contain, that will stand for one, something's off, there's no electricity, there's no signal. So we call it off bits. Okay, and if it's 1, that means there's signal, and that signal is on. We call it on bits. Okay, and there is something else we need to understand. If the on bits can be, for example, you have an LED light. It says off, then on, off, on, then off, then on, then off, then on, something like that. So whatever up here, it's 1 1 1. Whatever down here is 0 0 0 and then 1 1. So if you combine those numbers, and you've got 0 here as well, it becomes something like this: 0 1 0 1 1 1 0 0 1 1. But the numbers can continue as a stream. What we need is, for IP address, we divide it into 8 bits. That makes it easier as well. And now the on bits, we say they stand for network bits. And what's that? Network bits. We'll talk about that. And then this says off bits, and we call this one host bits. Okay? Host bits. Now, if we have the IP address and we have those numbers, there is a categorization or some way we can identify what are we dealing with, and they are called classes. So the IPv4, we divide them into classes. We call class A, and then class B, class C, D, and E. This is very important to understand. For A, we have those bits organized in this way, N, and they have H, H, H. And then for B, we have N, and then N, and then H, and then H. For C, we have N, N, H, sorry, N, another N here, and then H. I will talk about those separately. They're used for something else. And let's focus on these 3. If we pick the first one, if it's N, it's network bits. And here the ones, we will use N. For zeros, we will use H. We will use small n, small h again. But for now, if you see the first one, which is class A, the class A, and we know it is N, and then that number is H, and then H, and then H. You can see the 1, the N here, it's all ones. That means 1 2 3 4 5 6 7 8, and the H will be 0 0 0 0 0 0 0 0, 8 of them. This H again, 0 0 0 0 0 0 0 0, and that one, the last one, 0 0 0 0 0 0 6, and 2 more. Now if you count how many bits are there, there's 8 here, no ones here, no one's here, no one's here, and that combination, it gives you a number called /8. And this number, we've seen how to convert binary to decimal. So if you have 1 1 1 1 and then other 4s, and if you follow the same process 2 to the power of 7 and continue that way, you will have a number as this 255 255. So all ones will have 255 255, and the 0 is just 0. This 0 is a 0, this 0 is a 0. So if you have a /8, or if you have 255.0.0.0, this is the same. We call this one subnet mask, and this is slash notation. This represents the subnet mask. For class B now, class B, we have N, and then H, and then H. The N here is 1 2 3 4 5 6 7 8. The N here 1 2 3 4 5 6 7 8, and the H here 4 zeros 4 zeros. Then the last one 4 zeros 4 zeros. And then if you combine here the 8 bits here, 8 bits here, no one's here, no one's here. If you combine all of them, that becomes 16, and you will see /16. And then we know all ones in decimal, they become 255, and then again 255, and then 0 there, and then 0 there. So if you have /16, or if you have 255 255.0.0, they're the same. And class C, you can say for class C, it is N, and H. And if you see, this will be 8 1s 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8, and then 8 zeros here, 4 here, and then another 4. If you combine this 8 plus 8 plus 8, that gives you /24. And in decimal notation, the subnet mask is written this way: 255, 255, 255.0. So if we now combine what we have seen from the previous numbers here, and if we see 192.168.1.1, that's an IP address, but it needs something called subnet mask. And why we need that subnet mask? It's because we need to identify groups separately from others. There's one network here. What identifies the network is the subnet mask. So if we have 192.168.1.5 from the previous example, and the subnet mask is class C, original class C, we can either write /24, or we can write 192.168.1.5 and then put the subnet mask fully as decimal 255 255 255.0. That's an IP address with its subnet mask. So what's this subnet mask, and what's the IP address? Let's say you live in a country, and that is the country, and then you live in a city, but there are multiple cities in that country, and then in this city you live in a street and a house number, and that's your specific address. If I want to send a letter to you now, that letter will leave maybe from another country, and it comes to this country, and then from this country it goes to your city, and then from your city it goes to your postcode or your zip code, and it comes to your area, to your door number. Now the big number here, the country, it's called network. We cannot assign that to a specific person. One person would not say anything coming to that country is my address. It's shared by all. And then there is something called, the first one is network address, and the second one is called broadcast address. These two cannot be used by a specific person, like in a city. So we have to dedicate that, we have to explicitly say they're not for someone, they're shared by all. So we have to assign separate IPs. But when it comes to IP addressing, we will get a subnet mask that says you are in this city. Another subnet mask, which is maybe 255, 255.0.0 will be another city. So subnet mask will create isolation between networks. One subnet mask here, one subnet mask here. Okay, I think that's all for now. Thank you very much for your time.